Hi everyone, I am Miguel Rodrigo, and in this short video, I'll explain how a network switch forwards frames using its MAC address table. We'll try to answer 3 questions from this activity in this module of Cisco's networking course. First, let's look at this scenario. A frame is sent from device OB to OC. You can see the details in the frame as well. So the source MAC is 0B and the destination MAC is 0C. In the switch's MAC address table, we already know where 0B, 0C, and 0E are located. So for the question 1, so since this is a unicast frame, which means it's going from one device to another device, the switch will look up the destination MAC address in the MAC table. So the destination MAC address is 0C, and we can see that it is listed under FA5 in the table. So that means that the switch knows exactly where to send the frame. So the only answer for this question is the FA5. So let's check this FA5. Moving forward, since 0B is already in the MAC table and listed under FA3, the switch doesn't need to add it again. So the first statement is false. The second statement, is the frame a broadcast frame? No, it's addressed to one specific MAC, not all devices. So again, the second statement is false. The third statement, this is a unicast frame and the destination MAC is found in the table. So it's forward to one specific port only. So the third statement is true. The fourth and fifth options talk about flooding or dropping the frame, which only happen if the destination MAC is unknown or if it's not a unicast. But in this case, the destination is known, so both options are false. So let's check that. Then let's try to check if it's correct. And yeah, it's correct. Now let's move forward to another problem. Now in this scenario, a frame arrives with source MAC 0F. The destination MAC is 0D. The MAC address table currently has 0F in FA1 and 0E in FA10. So the switch received the frame on FA12. So for the first question, where will the switch forward the frame? So first, the switch learns the source MAC 0F and saves it on FA12. And it doesn't find the destination MAC 0D in its table, so the switch will flood the frame. It only floods the active ports that are in the same VLAN and are configured to receive frames such as end devices. So in this lab simulation, only ports connected to PCs are configured to receive the flooded frame. And those are FA1, FA3, FA5, and FA7. What should be ticked in this question is FA3, FA5, and FA7. And moving forward for the question 2, now let's break this down. So for the first statement, this is correct. Since the switch learns the source MAC 0F and records it with the port it arrived on, say FA12. For the first statement, this is true since it's a unicast frame, but the destination isn't known, so it's flooded. So these ones are correct. So let's try to check that's our answers. And yeah, it's correct. Now for the last problem. Now in this scenario, we are given a frame where the destination MAC address is 0C and the source MAC is 0E. Now looking at the MAC address table, MAC address 0C is found on the port FA5 and the MAC address 0E is found on port FA9. Now this tells us that the device 0E, which sent the frame, is connected to FA9 and it wants to send the frame to device OC, which is on FA5. The switch will forward the frame to the port where the destination MAC address is located. And since MAC address 0C is listed under FA5 in the MAC table, the switch knows exactly where to send it. So the correct answer for this is FA5 only. So FA5 should be the only one that's checked in this question. Move forward to the second question. What happens when the switch forwards the frame? This frame is not broadcast, it's a unicast frame. That means it has one specific destination, which is MAC address 0C. And since the destination is known in the MAC table, the switch sends it directly to that port, in this case, FA5. So the correct statement is frame is a unicast frame and will be sent to specific port only. So let's check that. And yeah, it's correct. And that's it. Thanks for watching, and I hope this helped you understand how switches make forwarding decisions.